Okay, so let's define differentiation for LP function. So a function f in LP Rn, okay, is differentiable in LP in respect to the kth variable, kth. Okay, so we are Rn, so differentiable respect to a kth variable if exists a function g in LP such that the integral Rn absolute value fx plus h ek minus fx all over h minus gx p dx goes to 0 when h goes to 0. Okay, so this is one. Okay, so this ek, it's like a canonical vector in the way that ek has the kth coordinate equal to 1 and 0 in the others. Then if this j exists, so that happens, this limit goes to 0, then this g will be called the partial derivative of f with respect to the kth variable and in the LP norm. Okay, so if you remember, we had a theorem that we stated in the video before that said that the df dck c and it was equal to 2 pi xk f of x c or psi. I don't know how to pronounce that. Okay, and this was okay. Now to consider the converse result, that we are going to use the definition we just have written, and so there is another theorem that says that f is in L1 and g is its partial derivative as we just define it in respect with the kth variable in L1, respect to L1 norm in this case. So then g upside is equal to 2 pi I psi k f psi. Okay, so this is kind of converse result of the one that we stated here. So in the first theorem, we had xk multiplied by f that was in L1, and then you knowing that, you knew that f, the transform of f, is going to be differentiable, and that you can express it in this way, the derivative in psi k. So now we define differentiation for LP, and now we have the result that the transform of the partial derivative, you can say. If g was the partial derivative of an L1, then the term form is going to be the original f multiplied by this factor psi k to pi I. Okay, so from the previous results we can obtain the following formula. Suppose that P is a polynomial, but a polynomial of differential operators. PD f transform psi will be equal to P minus 2 pi I x fx C k. And another thing that one can obtain from the previous results is that PDF, let's put it all transform, psi will be equal to P 2 pi I psi f psi. Okay, so remember, P is a polynomial in n variables, and that it has a d inside is because it's a differential operator associated to P. Okay. Okay.